What is the electric field inside a conductor in electrostatic equilibrium? To answer this question, let's look at the words we have used. Electrostatic equilibrium. Well, from Physics 4A, which is at West Valley College, that is our first calculus-based physics class, we know static equilibrium is the state in which an object has zero net force acting on it and it's stationary. So a stationary object with zero net force acting on it is an object that is considered to be in static equilibrium. Now remember, if it has zero net force acting on it, its acceleration is zero. The electro part of this means charge. So electrostatic equilibrium means that our charges are not moving, and the net force on each of them is zero. So what is the electric field inside a conductor in electrostatic equilibrium? Well, let's think about it. If we had a charge, let's say we had a charge right here. If this charge experienced a net force, it would begin to accelerate in the direction of that net force. Now, if it was accelerating in the direction of the net force, well, one, we know that the force is equal to the charge times the electric field. Well, if it were to accelerate, then there would have to be a net force. If there were a net force on that charge, then it would not be in static equilibrium, because equilibrium requires the net force to be zero. So if the net force is zero, the electric field must be equal to zero for a charge to be in electrostatic equilibrium. In other words, the electric field everywhere inside a conductor in electrostatic equilibrium must be zero, because otherwise there would be a net force on our charges, causing our charges to accelerate, meaning that they are moving and they're not in equilibrium. So the electric field is zero for conductors in electrostatic equilibrium.